Hello and welcome to the next episode on this beginner tutorial on how to create your first DirectX application in C++ from scratch. In the last episode, we created some normals and vertices for our box. We also changed the pipeline in terms of not using the color attribute of each vertex anymore, since we will be shifting towards a quote-unquote material system. We will create a simple material system that will apply a so-called diffuse color for our object. It basically means that what is the fundamental color that the object reflects when light shines upon it. Since it's diffuse coloring or diffuse lighting, it means that there are no reflections, there are no speculars on it, there's no roughness, anything like that. And that suits our outset or goal for this video series here to create a toon shader anyway, because we won't be doing materials in this shader. So how do we create a material buffer? Well, first we need to be able to bind our material buffer to our pipeline. So we need to update our root signature to be able to actually bind a data structure to another input slot. We would like to be able to change the color for future objects. You could do that with a descriptor heap and a series of constant buffers. I do constant buffers page allocated in my own project, but for this project we will do something a bit more simple. We will simply expand our root signature here to contain another root parameter that is also a constant buffer with just the shader register 1 here. And we will update the number of parameters in the root signature in total. We will not be doing sampling since we're not doing textures, we're only doing materials. All right, so that's basically it. We've added a constant buffer to our root signature at the second input parameter slot. We would like for this constant buffer only to be visible to our pixel shader, since that is the part where we actually handle lighting and coloring of our pixels. So it's only relevant for that, at least for now. So therefore we set the shader visibility to that. We will create one material for this pipeline here. First, we need a render data structure, which we will call a material, cell shaded, cell shader maybe, and we will store a float 4 here, which we will call the diffuse albedo, and we will initialize that as black, but with an alpha of 1. Okay. We want to create a buffer on our render API here. Let's do a D12 resource where we set it as a material buffer 1, so that we could do several. And we of course want to initialize that. We will initialize it with our device. We will set it with the size of oh, wait a minute, we're creating a constant buffer here, so we need of course to create a aligned data structure that has some padding that fits the GPU cache of the different hardware vendors. So we do a size of a aligned size of the material cell shader. We want to create it on a default heap, and we want to create it in our resource state common, since we want to store this as something that we can access fast on the GPU on the default heap. And as you might recall from a previous episode, when we upload things that are vertex or constant buffers, we actually want them to end up in a specific resource state when we upload it. So let's see. We want to upload the material buffer here. We want to upload one material, and let's see, the rest is correct. Okay, let's just specify a name for this one so that we can find it inside our debugging tools material buffer. We will call it material constant buffer number 1. And we upload it to the GPU, but we haven't passed it any data yet. So let's create a material here. We will set the diffuse albedo to something like, maybe we want a primarily red color here, extremely red color, and maybe with a marginal of blue in it. Let's see, let's try that. And we simply reference our material here and upload that. All right. We've uploaded the material. Let's bind it to our draw calls here. We need to set the second root parameter to our material buffer GPU address, and now it's bound to the pipeline. This means that inside our pixel shader, we can actually access it. We can also bind it. Can you remember how we bind it? Maybe. We will simply call this material because we have no, we don't care. Maybe material data, and we will do a float for and call it diffuse albedo. And we will bind it to this pipeline. Remember, we can only do this inside our pixel shader because it's only visible there. And we will call this global material data, and it will be in our register B1. And now we can access it. So let's try doing that. Right now we will simply return the color of the albedo. Let's see, we have a problem in terms of the compilation here. Whoops. Undeclared name here. There we go. There we go. We suddenly have a material, but the material does nothing in terms of lighting. But at least now we can specify the color of our object here. Let's see. I wanted to change the color a bit. Maybe tone it a bit down in terms of the blue. That looks a bit better. All right. So now we have a material that resides on the GPU default heap. And that's great. Actually, that is basically what I wanted to do. You could put these into a vector and create a series of different materials and simply just reference the appropriate material down here. You could do that. Well, maybe we want to do that. Okay. No. Well, maybe we will do that in the future. But since it's probably something that we would like to do, I think that we should actually move this step up here, create a light source, and actually collapse this into this episode as well. And then we can spend our next episode only doing the actual toon shader stuff. Yeah, let me see how far this recording went. It's only 10 minutes, so it's fairly short. So we will be creating some information that we want to what do you call it? Store in our scene here. We want to create a light structure. We want to give it a XM float 3 position, which we will initialize as 0. We want to, since DirectX 12 and shaders in general prefer things that are byte aligned with 16-byte alignment, I think, or is it even 128 bits, which would be 32-byte alignment. Yeah, I think it's that, but anyway, to make full use of the resources, we will have to try to arrange our data so that 4 floating point numbers are listed together, and then bigger structures are kind of like arranged so that everything is aligned nicely. So we will do something like a strength value that we will set to 0, and then we will of course specify a direction vector. And then we will do some padding here, which we don't care about. Because we will simply create a scene light here as part of our pass data. We will declare that inside our pass data struct here. We will create a light struct, which we will fill with a float 3 position, a float strength, and a float 3 direction, and a float padding. So now if we create an array of these, if we want multiple lights, we can always do that. Okay, light data, lights, maybe just one light. Okay. And since we probably want this in our well, the problem is now that in our root signature we have actually specified this that this is whoops, that this is only vertex visible, but maybe we can combine flags. Is there a combined flag? Shader. Okay, let's do all. Our pass data will be available everywhere. All right, look, I think everything should compile still. Yeah, but right now we do not store any lighting information. It's fairly easy to store some lighting information. Whenever we, I think we do it in our update step here. And we could do a light array. Let's see, view projection, constant pass data. Maybe we want the lights, which support up to 8 lights. In our renderer API here, we set the first light position. Yes, maybe it doesn't. Maybe we don't want a light position. Maybe we don't care about the light position. Maybe we want a overall directional light, which will point downwards, straight downwards. So we do -1. We do a normalized vector here, and we can set the strength to something, maybe an arbitrary value of 1. We don't know what it does yet. And then we simply want to cast this as a byte pointer because we want to offset it. Plus a size t. Is that a size t? It is a size t. Okay, plus the size of the pass data, and we simply copy the lights here, the first one, and copy the light data structure over each frame. This should be, no, it's not fine. Oh, is that it? There we go. All right. Okay, we could do these initializations if we wanted to. We don't care right now. So now we can upload a light. We can set its direction and strength. We can control it all from the application side. And right now we are set up in terms of doing our actual shader program. Great stuff. Great stuff. So yeah, maybe we want to do a last episode here, handling rotation of objects, scaling, moving. Yeah. Okay, I'll add that as a last feature. Now I won't be adding any more features, I think, because this project is kind of like growing steadily. Yeah. So that's it for this small video. In the next video, I'll toy around with a simple tool shader. Yeah. So stay tuned for the next episode. if you found any of this helpful, useful, or inspirational, or if you have questions or something that you would like to know, feel free to comment down below. Also, feel free to like, subscribe, or in other ways support the channel if you enjoy any of this content. In the next video, I'll be starting on the toon shader. All right, hopefully I'll see you around. Bye bye.